Hi all, welcome to Security and Privacy in Cloud. I'm Lavanya, who's working as an assistant professor of CSE department. And today, in this video, we are going to discuss about fundamentals of cloud security concepts. The topic is conventional and public key cryptography. So first, what is meant by the conventional encryption? So it is a cryptographic system that uses the same key to used by the sender to encrypt the message and receiver to decrypt the message. It was the only type of encryption in use prior to the development of public key crypto system or encryption. It is still much preferred of the two types of encryption system due to its simplicity. It's a relatively fast process since it uses a single key for both encryption and decryption. In this encryption model, the sender encrypts a plain text using the receiver's secret key, which can be later used by the receiver to decrypt the ciphertext. And this is one of it has some of five ingredients or the five components. That is the plain text encryption algorithm, secret key, ciphertext, and decryption algorithm. So in conventional thing here, if you take in this diagram, the Bob, if he wants to send a message to Alice, here suppose hello Alice, just will be encrypting by means of some algorithm. It uses the Alice public key to encrypt that message. And in turn, while decrypting that particular message from the Bob, the Alice it uses her private key to decrypt that message. So it will be back to the hello Alice. So this is all about the conventional encryption. So the encryption algorithm here it uses some various transformations on plain text to convert into a ciphertext. And the secret key or the public key or private key the using VR is that uses as an input to the algorithm. The encryption algorithm will produce different outputs based on the keys used at that time. And here, for decryption, it uses the encryption algorithm in reverse. Cipher key and secret key is input here and it produces plain text as an output. So this is what here they have explained. Suppose if Alice wants to send a message to Bob, the message is called as a plain text. Now, to avoid the hackers reading the plain text, that it will be encrypted using an algorithm and a secret key. This encrypted plain text is called a ciphertext and is using the same secret key and encryption algorithm which runs in a reverse. B, there is the Bob gets a plain text of A and thus the message is read and security is maintained. The main requirement for securing the use of conventional encryption, the first one is that we need a strong encryption algorithm. Second one, the sender and the receiver must have obtained copies of the secret key in a secure fashion and must keep the key secure. If you take the advantages of conventional encryption, it is simple and this type of encryption is easily to carry out and it uses fewer computer resources. That is, the conventional encryption does not require a lot of computer resources when compared to the public key encryption. And third one is that it is very fast when compared to other encryption techniques. And it is much faster than the asymmetric key encryption. The disadvantage or the drawback, the origin and authenticity of the message cannot be guaranteed since both the sender and receiver uses the same key. Messages cannot be verified to have come from a particular user. It isn't much secure when compared to the public key encryption. And the third one disadvantage is that the receiver, suppose he or she lost the key in the sense he can't decrypt the message, and that's making the whole process useless. And the next one, fourth one, is that the key does not scale well to a large number of users because both the sender and the receiver have to agree on a secret key before transformation. So this is all about conventional encryption. And this, as I told, the advantages of conventional simple, it uses fewer computer resources and it is fast. So this is the drawbacks of the conventional encryption model, which I have explained earlier. The originality and compared to the public key, it was not secure. If he or she loses what is that the key in the sense, the whole process will be useless and it does not scale well. Now we will switch on to the public key cryptography. Here it uses some resources. It's a method of secure communication that uses a pair of keys, a public key and a private key, which anyone can use to encrypt a message or verify signatures, and a private key, which is a kept secret and is used to decrypt messages or to sign documents. And it ensures that only the intended recipient can read an encrypted message that is signed by the message truly comes from the claimed sender. So this is an architecture or the diagram for the public key crypto subsystem. Here, the source A, it produces a message in a plain text, say for example, x is equal to x1, x2 till xm. The no, the message or the elements of x or letters in some finite alphabet. The message is intended for destination B. This is the destination B. And here in this destination B, we will be generating a related pair of keys, public key, that is a PU. Here you can see that is PUA is nothing but public key and private key. And here this PR is nothing but the private key. And PRB is known only to B. This private key, if you take like PRB, this only knows to the B. Whereas the PUB, like if you are going to use some public key in the concepts, it is publicly available, therefore accessible by A. So with the message of X and the encryption key PUB as input, a ciphertext Y is equal to Y1, Y2 till Y1. Y is equal to encryption of PUP, comma Y. And similar to that in the internal receiver. So this is a message source. Here we'll be using some decryption algorithm. And inside, if you take in the destination B, here we'll be using some encryption algorithm to choose the destination. The in position of the matching private key, which is able to invert the transformation, X is equal to, for example, if I'm giving like decryption of PUA, comma Y, and observing Y and having access to PUB but not having access to private B or X, must accept to recover the X. It is assured that the adversary does not have knowledge of the encryption E, and so here you can see that the focus of effort to recover the X by generating a plain text estimate X. However, the adversary is interested in being able to read fusion messages as well, which can A's attempt is made to recover PRB by generating an estimate of PRB. So this is the key pair source. Here the message will be just occurred by the decryption algorithm, thereby follow the cryptanalysis method. This is all about the public key crypto system. So if you take the applications of public key crypto system, it is used in three categories like encryption and decryption, digital signature, and key exchange. So if you take the encryption and decryption, the sender encrypts a message with a recipient public key. And the second one is that the digital signature where the sender signs a message with this private key. Now signing, which is achieved by a cryptographic algorithm and applied to the message or to a small block of data. That is a function of the message. And key exchange is nothing but two sides cooperate to exchange a secret session key, and several different approaches are possible involving the private key as one or both the parties. And the next topic is that how does TLS or SSL, it's used in public cryptography. But before that, I would like to share what is meant by SSL or TLS. So SSL is nothing but it's a secure socket layer encryption, and it's more modern and secure replacement. And if you take TLS, transport layer security encryption, which protects the data we send over the internet or a computer network, this prevents attackers and the internet service providers from UV or tampering with data exchange between the two nodes. Typically, uses web browsers and the web or app server. Most website owners and operations or operators have an obligation to implement SSL or TLS to protect the exchange of sensitive data such as passwords, payment information, and other information considered private. So, how does use public key cryptography? So, to keep our internet connection secure, it has in two main ways. So, here, asymmetric encryption is used to establish a secure session between a client and a server. And symmetric encryption is used to exchange data between the secured session. A website must have an SSL or TLS certificate from the web server or domain name to use SSL or TLS encryption. So once installed in the sense, the certificate will be enabled to the client and server to securely negotiate the level of encryption in the following steps. The first step, if you take, the client contacts the server using a secure URL, say for example HTTPS. So HTTPS is used for security. Like if you take an example for banking website or some secured the cyber security wall or cyber security websites, they'll be using the hyperlink as HTTPS. If you're going for a normal link, normal grocery, say for example Zomato or something like that, you can't able to see that HTTPS because it's not secure so much. So that what they'll be doing is that the server sends the client certificate and public key. And second point, the client verifies this with a trusted root certification authority to ensure the certificate is legitimate. And the third one, the client and the server negotiate the strongest type of encryption that each can support. The client encrypts a session or the secret key with the server's public key and sends it back to the server. The server, in turn, decrypts the client's communication with this private key and the session is established. And the last one, if you take for contacting the server, the symmetric encryption is now used to encrypt or decrypt the data transmitted between the client and the server. So, and then one more thing, if you take the TLS or the SSL, what they will be doing is that it is used in so many protocols and which used in like what base you are going to use or what aspects they'll be using, something like that. It will be tested. So based on the tested method only, it will be using. So um, here also it contains some key points about the TLS public cryptography is that key pair, authentication, session key exchange, symmetric encryption. So how does it work if you take? There are so many types which is involved in this particular area. And why we are using this public and symmetric cryptography is that public cryptography, it's secure, but competitively it is expensive, right? And if you go for the symmetric encryption, it's much faster and efficient for the data transfer. But if you're combining both TLS and SSL, asymmetric encryption, which is used for key exchange, symmetric encryption is used for secure combination. If you take, there are so many TLS versions, like transport layer security 1.2 or versus TLS 1.3. Transport layer security is a successor to SSL. It is used to secure the internet communication. The major versions, as I told, is that TLS 1.2. So the TLS 1.2, what they'll be doing is that it is most widely used around the world, because if you take the TLS 1.3, it is faster and more secure. But rather than 1.3, because it's more expensive, right? So they'll be opting like 1.2 more probably. And if you take in TLS 1.2, there is so many steps involved, like handshake process, session key, and data encryption and integrity. What is meant by handshake process is nothing but the client sends a, for example, hello client message, which is listening to the supported cipher. The server inter responds with the server hello, and its SSL or TLS certificate, which contains a public key. And here, the client will be verifying the certificate using a trusted certificate authority. There will be a pre-master secret which is generated and encrypted with the server's public key and sent to the server. The server decrypts it using its private key. So this is how uh, we should be established in TLS 1.2. But the drawback of TLS is that it takes more handshake steps, which leads to higher latency. And it supports weaker ciphers like RSA key exchange or CBC mode, a potential security risk. And if you take the TLS 1.3, as I told, it is more secure and faster. It improves the security and performance by simply handshaking and removing the weak algorithms. And if you take, it contains only one round trip. That is one RTT we used to say when compared to the TLS 1.2. And no RSA key exchange is involved in here, which is used as elliptic curve cryptography or Devi helmet. And the client and server immediately agrees on a session key, which reduces the latency. And it involves some stronger encryption like TLS 1.3. If you take, it goes for some stronger cipher suits like AES GCM or CHA-20, and it does not support for any old weak cipher like RSA key exchange or MD5 or SHA-1 or CBC mode, something like that. And the third one, if you take data integrity and security enhancement, it uses some authenticated encryption with the associated data cipher, which provides both encryption as well as authentication in a one step or a single step. And second point is that it uses a forward secrecy, which is enforced, which is even a private key is compromised, the past communications will be remaining secure. And the last one is that a zero round trip time or zero RTT reception. In repeat connections, if we take for TLS 1.3, it allows a zero RTT or handshakes, which is faster secure reconnection. Sorry. And it also reduces the latency in web applications. And so this is about the applications of public key crypto system. So here we can able to classify the public key crypto system into three categories. First one, encryption and decryption, and digital signature and key exchange. So the sender then encrypts a message with the recipient public key, and the digital signature, the sender signs that message with its private key. Signing is achieved by only means of cryptographic algorithm which is applied to the message or to a small block of data, that is a function of the message. And last is about key exchange. Two sides which is cooperate to exchange a session key with several different approaches, which I have seen in the previous slide. It involves a private key of one or both the parties. So this is all about the applications which is involved. And so this is the main difference between the conventional encryption and this is the public key encryption difference. So, what is meant by conventional encryption, which we have seen here in the previous. Yes, just recollect that, and you can just comment in the comment box. So here, the same algorithm, the same key is used for both encryption and decryption. And here, if you take only one algorithm is used for encryption and the decryption, with a pair of keys, one for encryption and one for decryption. The second point is that it uses the sender and the receiver must share the algorithm as well as the key. Here in the public key crypto system, the sender and the receiver must each have one of the matched components or the matched pair of keys. So this is about and the next one is that a symmetric algorithm, like example, if you take AES, DES, Blowfish, RC4, and the public key like asymmetric algorithm can take like RSA, DSA, Diffie-Hellman key exchange. Okay, and the next that is the needed for security. In case of security, if you take the key must be kept secret in case of conventional encryption, whereas in public key encryption, one of the two keys must be kept and it should be secret. And the second point is that it must be impractical to decipher a message if no other information is available. And here, it must be impractical to decipher a message if no other information is available. And the third point is that knowledge of the algorithm plus the samples of the ciphertext must be insufficient to determine the key. And here, the knowledge of the algorithm, along with that, one of the key plus samples of ciphertext must be insufficient to determine the other key. So this is the main difference between the conventional encryption and public key encryption. So when to use each or both in the sense, if you're going for secure symmetric encryption, you can go for conventional. No, if I just go for the public key in the sense, you can use like secure key exchange or the authentication like TLS, SSH, like which I explained in the previous slide. If you're combining both, you have to opt for TLS or SSL because that uses asymmetric encryption to exchange a symmetric session key, which is in use for a bulk data encryption. Okay, so this is all about the difference between the conventional encryption and the public key encryption. I hope this video will be very useful. So this is all about the conventional and public key encryption. So thank you all. Thank you.